And presentation is open for questions. Joe?
So if you go back to, I think it's your second slide, the number of electrons. So it's 65.0000. When will it ever be not a whole number?
You mean if it's possible?
Yeah, so would there ever be a case where there's like a quarter electron?
I think it's possible. In some more complicated molecules, it could be possible.
Let me help and address the question. There are two interpretations of quantum theory. One is wave function square is a probability to find electron at a given place, and it is assumed as being correct. And there is an alternative interpretation where wave function square is the density of charge in a given point of space. This is not philosophically ideal, but it is practically helpful interpretation. There are many people who still argue about it. And if you accept second interpretation, which you need not, but you may know about this interpretation, then you do not have any problems to deal with fractional charges, which might be not real, but could be an auxiliary tool in your intermediate calculations. Okay? So more questions to the speaker. Austin.
You go to the density states, the cation.
The graph, right?
The plot.
You mean the graph?
Or, yeah. So how did you pick the range for the x-axis?
You mean the outer energy?
Like from -10 to 0. How did you pick that range? What was your decision making?
I did not pick by myself. I guess it's created by the in-car to file.
Did it automatically?
Yes. I guess we could manually pick it by modifying in-car, right? How do we manually pick it?
It's when you're creating the density of states, when you're running the code, the DOS norm, then your minimum and maximum energies that you input, that's your minimum and maximum for your x-axis.
Okay.
But typically, what you do is you look at your gap energies. And you usually do that by looking at your states file. So let's say my HOMO is at 5. Then I'm going to go maybe 3 or 4 below that. And then let's say my LUMO is at -2. Then I'm going to go 3 or so above that, so that your gap is in the middle, and you're going to have a little bit of range on either side of it. Does that make sense?
So that's why you need your states file?
One of the reasons, yes.
Okay, I gotta answer Kevin's questions. Yeah.
Good questions, good answers. More questions. Okay, let's go to the slide number 6. Yes, and everyone in the room is invited to proofread this page for any scientific inconsistencies, including the author. Weijing? Do you agree with every single letter here, or something might need to be corrected?
You mean the 0 and 1?
Huh?
Here? Spot?
This is
This is
fine.
correct.
This is fine.
Okay.
This is correct.
Right? Is that multiplied by 1, or is that some other kind of command?
Multiply by 1.
It's multiplied.
Even more specific. Does everyone agree with LUMO minus 1 multiplied by 1. Should it be exactly LUMO minus 1 or something else? If you put it in the form of equation. Would you explain by words what should be in this place? What does this equation stands for? And if anyone in the room knows the answer, please give a signal.
Well, I'll give you a hint. What do you have typed just underneath that? It kind of helps explain. So just to clarify, you're asking him to define the piece that's in the parentheses, correct? That says LUMO minus 1. You're saying, what does that mean? Okay.
Yes.
Does that mean the number of the stage? If it's total 40 stage, there's a how many out of these are unoccupied?
Mm-hmm.
So if there's 32 occupied, so there are going to be 8 unoccupied. Right?
But LUMO will be 33. How does it relate with your 6 unoccupied? Should be different equation.
Okay. I don't
So
remember.
I just suggest that we introduce the total number of orbitals or maximal number of orbitals, and then here when we do this number of orbitals minus LUMO minus 1. So if there are 40 orbitals and your LUMO is 33, then and minus 1, this will give 6. Make sense?
Okay.
Okay. Should it be 1 or something else here?
Something else.
So what is something else?
I don't remember.
Any guesses?
2?
Okay.
Okay,
Good.
0.
Yes, excellent. Which stands for unoccupied, right?
Okay. Oh my god, yes.
So this number 1 or 0 stands whether the orbital is occupied or unoccupied. So if you put 1, if you mean you have a highly anionic model that was populated with 7 additional electrons, which would be a little strange. So you 0. More questions? If no, let's thank Weijing once again.